Hello, computer nerds. You ready to do some more video game work? Well, me too. As you recall, last episode, we got some basic functionality going. We got the planet in there. We got the satellite to move around it. We got the targeting cursor to move around by the mouse. And we got it to fire bullets very rapidly. And we came up with a list of things to do to follow up to make it better. Number one was to change the rate of the bullets so we don't blow our ammo supply in one press. And the big one was to do collisions, to have the bullets hit something. And so we wanted to make a target, a bullseye target to have something to shoot at, and then do some explosions. Well, I got good news. We got the targets in there. We slowed down the bullets, and we got the collision working. But the collision took a long time, and I'm going to have to explain some of the details of it. But why don't I show you how it's looking so far. So, have a programmer, have some coffee, put some gears on, and let's make some code. Okay. All right. Let's bring up the Unity, and we'll put that on full screen. So here we are. We're back on the Unity. We got our satellite flying around, and we got a target down here. And when I shoot the bullets, you see it's not so rapid fire. And I can shoot at this target, and look, the bullets disappear. And then there's also the planet. When I shoot at the planet, the bullet disappears. But I want you to notice something. If I'm going at an angle here, it hits the corner of the planet. It doesn't even hit the planet, it just disappears. Same with this target. If I don't actually hit the target, but I pass by the corner, it disappears. And so what's causing that? Well, this is what we call a simple collision detection. And for a game like this, we're going to have to do a much detailed collision detection, which we call PerPixel. So I'm going to switch over to the overhead camera, and we're going to explain the difference. All right, here we go. Okay, here we are at the 3D overhead view. Everything should be looking okay. And let's say this is our playfield. And here is Mr. Planet right there in the center. So Mr. Planet is a sprite, and every sprite, every texture, 2D sprite, 2D texture, has a bounding box around it, right? This is the actual picture of the planet, but the area which it draws to is this rectangle around it. It's called the bounding box. It has the left and the right, the top and the bottom, and this is how it keeps track of it in the game engine. All right, we have Mr. Satellite that flies around it, and we have our Mr. Target here, and you can see they all have bounding boxes to keep track of where they are on the playfield. And when we shoot, if we're right here, and we shoot Mr. Bullet also has a bounding box. It's actually, since the bullet is a square, it's actually very tight around the bullet. So if this is shooting at this target here, right, the bullet is going to travel along this line, and what simple collision does is it looks to see if the rectangles cross at any point. It's rather easy to see if, mathematically, to see if rectangles are occupying the same space. So it's coming along here, and finally it crosses this rectangle about that point. See, and it's not hitting the planet, it's just crossing that rectangle. And it goes, oh, I've hit the planet, and boop, we destroy the bullet. So that's not going to work. But if we're a little bit farther here, then it can follow along and hit the planet. But it doesn't actually, or it doesn't hit the target. It actually hits this bounding box and disappears. So this is what we call simple collision. It just checks the rectangles. Okay, so this would hit the simple collision detection, but that's not going to work with this. So we need to do per pixel collision detection. And the way you do that is you have to find out the area that's overlapping, okay? And then we're going to count the pixels inside here, and we're going to compare the pixel map of this with the pixel map of that just on this area that's overlapping. So we can't just use the 3D units for our spatial recognition. We need to calculate the pixels, and this is why you got to have the same pixels per inch, the same pixels per unit on your playfield, because we're going to be comparing pixels to pixels, and they have to be exactly in the same dimension. So let's do a little bit of reminder here of how we can calculate the pixels of everything. So the game is running everything in 3D units because it's a 3D game, and our playfield should be like 16 by 9. I don't think I have enough space here to show all that. But the game in 3D units has 0, 0 in the center of the screen, and then anything to the left here is going to have a negative x value, and it's usually like -1, -2, -3, -4, -5, -6. And this way it's positive, +1, +2, +3, da, 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 da. And then this is the y, so it's +1, +2, +3, +4, -1, -2, -3, -4. So this is how you can find out your position in space. So let's say this is at +2x and +1y. So the pixels in here, the texture, the bottom left is always the starting point when you go to fetch pixels from the texture. So we need to find out where this is in pixels. So we're saying that this right here is +2, +1, right? That's the x and that's the y. How do we find out the pixel position of this? Well, remember what our units were? They're 80 pixels per unit, 80 pixels per inch. So if we multiply this times 80, we'll get 160, 80. So that's what this position is right here. And we know that this target here, we can look at the texture, and it says it's 1 by 1. And so 1 times 80 is 80. So this is the bottom left, and the top right is we add 80 to each of that. So I think that's 240, 160. Okay, so that is the bounding rectangle in pixels of this particular target. Okay, and so whenever we have something going through this area, and we need to compare it, we need to do the calculation here and turn it from 3D units into pixels. Then once we get the coordinates in pixels, then we can measure the overlap in pixels. Okay? So, let's say this is one texture, and this is another texture, and they happen to overlap. And let's say this overlap is 10 by 10. Okay, but this one happens to be starting at 70, right? For this right here is 0, and this is 80, 80, 0, 0, 80, 80. And so that's at 70, and that's at 70. This right here, let's say this is 40 by 40. All right, and so this right here is at 30, and this is at, oh, that's also at 30. Okay. So we know that this overlap is 10 by 10, but it starts at 70 for this guy, and but it starts at 0 and heads up 10. So we take right, let's say that's that, and let's say this pattern's like this. So we take 110 by 10 of the first texture and a 10 by 10 of the second texture, which we pull out of this region for this and this region for this, and we then go by each pixel, right? There's 100 pixels in here. We go by each one, and we compare to see if either of them have pixel data in it. If it's blank, usually that means there's an alpha. Usually a pixel has red, green, and blue values, and also an alpha value. So an alpha is the transparency. So if the alpha is 0, that means it's completely transparent. There's no image on the screen. But if it's not 0, then there's some kind of pixel data on there, even if it's something dark and blends with the background. So we check the first pixel against that first pixel, and if it's not blank and the other one is not blank, then we know we have two pixels hitting each other, and we can say we have a hit. Hit equals true. That's how we do PerPixel collision. Now we don't have to do it every single time. What we first do is check this. We do the simple collision to see if the rectangles cross at all. If they don't cross, we don't have to do that detailed of a check. So this is PerPixel collision, and this is what we need to do to deal with things like this, where we got a lot of extra space in the corners. The other thing you could do is which they do a lot in 3D games, is they'll make a whole bunch of rectangles and keep it close and tight to the actual shape of the object. So it's just a lot more comparisons of rectangles, but that doesn't make sense here in this pixel-based game. All right, so let's go back to Unity and we'll take a look at how PerPixel collisions works on the game. All right, so I've done the I've made the basic collision and I've done the PerPixel Collision. And what I need to do is I'll go to the bullet option here, go to my sprite collider, and tell it to do a pixel collision, just like that. All right, and so let's give this a run. So here we are. I can shoot the target, boom, and I can see if I can shoot around the planet. Yeah, see, it's not eating it. Okay. Now, if I can shoot this, and you can see that it's very closely hitting that. All right. I'm pretty happy with that. It still looks like it's hitting the corner a bit. Okay. Let's see. I think I need to go to the target and turn on the PerPixel Collision for that. All right, let's try this now. There we go. There we go. All right, excellent. PerPixel Collision's working great. All right, well, now the next step is I got to do the explosions, and I have to make the explosions eat out part of this planet here. So we're going to do that next time. It's going to deal with using an animated sprite, so that's going to be interesting. And then we're going to learn about using the PerPixel Collision to also eat away at a particular object, changing its mask. So that way the whole collision system will change based on this particular texture. All right, so that'll be fun. We'll do that next time on Planetary Defense version 2. Ooh, there we go. So, thanks for hanging out. We'll catch you next episode.